I'm Carl Johnson from the University of Connecticut, and I, along with my colleague Barbara, will be presenting our analysis today on global warming. Some believe it is real, and some do not. Everyone has their own opinion. Agreement varies across political lines, countries, and socioeconomic levels. Good, reliable data can tell a story. It informs us about the reality of global warming. Natural disasters are happening with a higher frequency and intensity. Are they related? Let's take a look at the presentation, and you can come to your own conclusion here today. The four main objectives are as follows. 1. To visualize drivers of climate change using sophisticated analytical tools, and in the process make new discoveries about relationships between greenhouse gases and global warming. 2. To highlight the increased frequency and intensity of natural disasters as temperatures rise, with both economic and human consequences. 3. To generate awareness and ignite a discussion of solutions to halt and someday reverse the global warming trend and showcase working examples of success. 4. To recognize that policies alone do not work. Solutions must be customized, acted upon, and then monitored by country with dashboards like the ones we are sharing with you today. For this project, we use sophisticated mining tools, including Tableau and IBM SPSS Modeler, to leverage all the rich data we acquired. We sourced this data from the World Bank, World Resources Institute, MDAT, the International Disaster Database, EPA, and NASA. This was across 194 countries. This chart, taken from NASA, is a land and ocean temperature anomalies. Temperature anomalies are important and used when evaluating climate and temperature changes, with a positive value for warmer than a base period and a negative value for cooler periods. This can vary depending on the base period you choose. The benefit in using anomalies is that the shape of the data will not change even if the baseline period changes. Throughout this presentation, we will be often referring to temperature through the anomaly lens. Using georeferenced latitude and longitude data from NASA, we created this visualization running from 1905 to 2015, with blue representing cold temperature anomalies and orange representing hot temperature anomalies. As you can see, as time progresses, the world and these anomalies are getting hotter. Now, my colleague Barbara will take over.
For this analysis, we employ the IBM SPSS Modeler to understand the relationship between global warming and greenhouse gas emissions. There were over 100 potential candidate variables from all the sources that we evaluated. The top four factors that emerged from this modeling were GDP per capita, forest area, electricity, and energy use. Why is GDP per capita the number one factor? Simply stated, GDP is almost perfectly correlated with CO2 emissions. From this Tableau visualization, we're looking at CO2 emissions relative to GDP in US dollars over time. The data runs from 1960 to 2014. It can be viewed for the world or for any country. There is a tooltip that reflects vital information used in the analysis and a regression equation. Now let's take a look at the temperature change and CO2 emissions. We're looking at temperature anomaly relative to CO2 emissions over time. In this case, we have a forecast. And in the forecast, in 2018, the model estimated that CO2 emissions would be 38 million kilotons, which is where we are today. This next visualization captures greenhouse gases across the globe from 1970 to 2012. In Tableau, you can build a parameter to look at different measures. So every time that I click on this measure, you'll see a different set of colors reflecting the gas intensity. The redder color reflects higher intensities. Let's just focus first on 2012 for not carbon dioxide, but total greenhouse gases. What we see are there's really 5 countries that are the top emitters. China, number 1, US, number 2, and then Russia, India, and Brazil follow at a lower level. We've automated this view so that you can look at the progression over time. Let's take a look. We see that China takes over the number 1 position from the US in about 2005, coincident with their industrialization. Now let's take a look at the top emitting countries versus the rest of the world. The red line represents the top emitting countries, and despite policy changes, the CO2 emissions continue at a nominal pace. However, the rest of the world is catching up. If we look at total emissions on a percentage basis, what we see in the early 1900s is that these other smaller countries represented only 6% of total emissions, but today, almost 35%. And this is something we need to be worried about. So what areas do we need to be concerned about? Let's take a look at this chart. This reflects the CO2 emissions relative to GDP growth. So we're in East Africa, and what I can see here is an increase in GDP and a big spike in CO2 emissions. But there are other areas in Africa that are also increasing at a rapid pace. And in South America, we see a similar trend. There are areas, not a lot, but there are a few where actually emissions are decreasing. I'm going to use Europe as an example. So you can see back in the early 1960s, there was an upward trend, which continued for about a decade. But recently, with policy changes, strategies for adaptation and mitigation, we are seeing a decline in CO2 emissions despite an increase in GDP. The top drivers of temperature change predicted by IBM Modeler included electricity and energy use. These together, taken in combination, are larger than forest area, which we're going to get to in just a minute. But for now, let's focus on energy and electricity. Worldview, energy is a dominant source of greenhouse gas emissions, as shown to the left. Energy serves a vital role in developing countries in providing electricity and heat, transportation, and manufacturing. The chart at the bottom left shows carbon dioxide and methane trends from all over the world, up 63% and 21% since 1990. The chart to the right shows access to electricity and emissions from electricity and heat, the red line, which has been steadily increasing over time across the world. This dash can be looked at for any year and also for any country. So let's go to China. In China, the picture is pretty clear. Energy is the dominant source of greenhouse emissions, and the source of that energy is electricity and heat and manufacturing. Carbon dioxide is on a big upward tear, although we do see some leveling off in 2014, and the emissions from electricity and heat increasing substantially over time. This next dash is linked to the prior. To the left, we're looking at electricity sources. In China, the problem relates to its high use of coal, but it has declined since 2009 was at 78%, down to the 73% in 2014. But China is working very hard to reduce the carbon emissions through renewable energy. There are other countries with above average emissions. Those include countries such as Mongolia, Poland, India, Australia, and even the US can work harder. Off to the right, we have a bubble chart which reflects alternative and nuclear energy use. The bigger bubbles reflect higher usage, and the colors reflect the continent. Iceland is a country that is leading the way. You can see off to the left, they use a high proportion of hydroelectric as well as renewable. It is important for the world to embrace renewable energy and to move away from fossil fuels. Now, let's focus on forest area, which was identified as one of the top drivers of temperature change. Why are trees important? Trees absorb a large amount of excess CO2 in the atmosphere. One tree can absorb as much as 48 pounds of carbon dioxide per year and can sequester 1 ton of carbon dioxide by the time it reaches 40 years old. As shown in the visualization, there is a strong negative correlation between the surface temperature change and forestation. At higher temperatures, you will see lower or reduced forestation. And there's a debate going on whether trees should be cut down. Clearly, trees are important to our environment and help to capture CO2. This map shows the amount of forest area as a percent of land mass for every country in the world. The color denotes the forest area as a percent of land, with the greener colors indicating denser forest areas. This dashboard can be filtered by year or automated over time. So let's automate and take a look at how the forest area has changed. I want you to focus your attention on South America and Africa. So let's get this started. You can see that the colors are becoming lighter. That is the land mass that has been converted from forest area to agricultural land. This visualization allows for a deeper analysis of the countries organized by continent. It showcases that many African and South American countries are losing a high percentage of their forest. As you scroll down, you can view any country in any continent. This visualization leads to a very important issue regarding why trees are being cut down in developing countries. It is estimated that 95% of natural forests have been lost as a result of agricultural expansion. Farms emit heavy concentrations of highly potent gas, methane, which is roughly 30 times more potent as a heat-trapping gas. The top portion of this visual shows Paraguay. The brown line is the agricultural land, which has been increasing, and the green line represents the forest area, which is declining. What is alarming is if we look at the emissions from methane, which have been increasing as the farming has also been increasing.
We talked about the drivers of global warming. Now we're going to demonstrate the link to natural disasters. In the past decade, we've experienced some of the biggest disasters in history. Unprecedented rainfall in India, record-breaking storms in the US, the strongest typhoon in 25 years to hit Japan, billions of dollars in damages, and hundreds of lives being taken. These disasters are affecting all of us. The visualization below measures temperature-related natural disasters, including floods, droughts, extreme temperatures, weather, and wildfires. As you can see, as the annual temperature anomalies increase, we also see an increase in the total number of natural disasters. In this data visualization, we show the occurrences of climate-related natural disasters from 1960 to 2018, taken from the MDAT database. You are going to see the disasters, including drought, extreme temperatures, floods, storms, and wildfires, flicker with increased intensity over time leading up to 2018. Two of the most prominent natural disasters, extreme weather and storms, and floods, are shown below. There is a strong causal relationship. Positive temperature changes have resulted in an increasing number of stronger and longer-lasting storms. As you can see in the chart, the number of extreme weather conditions increases as the annual temperature anomalies also increase. For floods, this is a similar pattern. Hurricanes are also getting stronger and lasting longer than ever. In the past 24 years, there have been 16 above normal hurricane seasons, the worst on record. In 2017 alone, Hurricanes Harvey, Maria, and Irma ruined the lives of thousands and cost a combined $265 billion. Beyond floods and storms, extreme temperatures and droughts also wreak havoc across the world. To the left, we show headlines which display the devastating impact that these extreme temperatures and droughts can have. Here we see a drought that affected 1.2 million people in Sri Lanka with the worst harvest in 40 years. In the chart to the right, we see a strong positive relationship once again between temperature anomaly and disasters caused by extreme temperatures and drought. Within Tableau, we can also see the forecasted values for the model up until 2028.
Turning to the topic of fires, climate change contributes to forest fires in several ways. Fires kill off trees and other plants that dry. They become kindling to ignite larger fires later on. Global warming in the period of La Niña increases the likelihood of dry days when fires flourish. The fires move rapidly in strong winds and they destroy everything in its path. The chart on the bottom shows that relationship again between temperature anomaly and the number of wildfires. We see an increasing trend, and it is growing over time. Now let's take a look at the occurrences of natural disasters. Again, we refer to the map from 1960 to 2018, but this time I'm going to hone in on just wildfires. The size of the bubble reflects the number of occurrences, and what we see in the United States is that The total affected was over 1 million. The damage over $40 billion. So let's go look at the areas in the US where wildfires hit. This is one of my favorite maps. It showcases the land burned by wildfires in the continental United States. The color represents the amount of acreage burned. And it showcases the data individually by year from 1984 to 2014. But what we see based on the deepest color red is that Idaho and California have been hit the hardest by wildfires. In California, there's a strong relationship between temperature change, particularly in the summer months, and land acreage burned. What I see from this chart is that there's much more intensity in terms of the fires burning a lot more land. But at the end of the data period, California experienced the biggest fire in 100 years, the California Camp Fire in Paradise. Killed almost 100 people and $3.5 billion in damages. Now let's look at Google search terms. So during the wildfire, there were a lot of searches for wildfire in Paradise, but not a lot going on for global warming, not a lot of searches. And what we've seen over time is a pretty substantial fall off. It appears from this data that people are not making that connection between the fires and global warming. Islands are being swallowed by the ocean. There are many islands in the Pacific that are vanishing. Sea level is rising so rapidly that a recent study found that 8 islands in the Pacific have already disappeared, in addition to other islands in Micronesia, with no evidence that they existed at all. Over 70% of the Earth's surface is ocean. Much of the heat trapped by the increasing atmospheric greenhouse gases is absorbed into our ocean, causing ocean temperature to rise and naturally expand. These charts pretty much say it all. We're looking at adjusted sea level over time. And this is just a trend over time. You can see it going out. But there's an inflection point in the early 2000s. We're seeing that the sea level forecast is projected to move to a higher plane. On the bottom of the chart, we see sea level rise and temperature change. Again, the adjusted sea level relative to the Earth's surface change. And we see a strong relationship. The forecast, as shown in the above trend, is increasing at a very, very high, fast rate. Our last note on oceans relates to glacier melt. As heat content increases, the red line, and it's been going up precipitously with an inflection point in 2003, we see the melting of glaciers. There's a before and after of a glacier in Alaska, where today it's green pastures. Do I need to say more? Climate change is impacting our world. A few recommendations: heightening awareness and deepening the understanding of climate change. Doing that through web-based education resources, but the link must be strengthened between global warming and disasters. Customized solutions by countries. For example, agricultural countries need emissions measurements and sustainable farming practices. Adaptation. It is unavoidable. We are going to have more disasters. We must make sure that we are ready, fixing walls, building dams, training, housing, food, medical. Mitigation through reducing the carbon footprint, particularly through the reductions of coal and shift to renewable energy. And planting trees. Technology and innovation is really the only way that we are going to get to our goals. Switzerland has their Climeworks, which captures CO2 at industrial level, satellites to spot methane leaks. But we need targets, actions, and measurements through some of the dashboards that we shared with you today. And worldwide involvement is the ultimate goal.